Hello friends, myself is Srishti Joshi. I am an BTech electrical engineer. Hereby welcomes you all to my channel. Today I am going to talk about construction of induction motor. So let's get started. As we have discussed earlier that there are two types of induction motors, single phase induction motors and three phase induction motors. In both the motors the construction is same, but there is one slight difference that in single phase induction motor the supply is given single phase, so there will be 2 wires, and in three phase induction motor the supply will be of 3 phase, so there are 6 wires in the terminal box. The three phase induction motor has 6 parts. First is stator, second one is rotor, third one is frame, fourth one is bearings, fifth one is cooling fan, and the last one is end shields. The stator is the stationary part and the power supply is given to the stator. The rotor is the rotating part which gives mechanical power to the load. Both the stator and the rotor is housed in a frame which provides mechanical support to the motor, and it also protects the motor from atmospheric conditions. Bearings are connected at the end of the shafts on both the sides and protects the motor from the mechanical wear and tear. The terminal box is connected on the outer surface of the induction motor in which the wires are housed. Let's start with the first part of the induction motor. First part is frame. Frame is the outermost part of the induction motor. It is made up of high graded cast iron. There is a hook on the upper surface of the frame to locate the motor from one place to another. The terminal box is connected on the outer surface of the frame for terminal wires. There is a name plate attached to the frame which contains details of rated voltage, rated current, rated frequency, rated speed of the induction motors, number of phases, starters, power factor, efficiency and torque. The common frame sizes are 48, 56, 145 and 215. So the second part of the induction motor is stator core. Stator is the stationary part of the induction motor to which the power supply is given. Stator core contains stampings of high graded silicon steel which are joined together to reduce hysteresis losses. The laminations are provided to the stator stampings to reduce eddy current losses. Inside the stampings, the windings are housed. These windings produce revolving flux when three-phase supply is given to the stator. So next part is rotor. Rotor, which is the rotating part of the induction motor, is housed inside the stator. It is short-circuited to the stator. As the torque is applied to the rotor, it rotates and gives mechanical power to the load. Now there are poles inside the rotor, so the number of poles decides the speed of the motor. The relation between speed of the induction motor and number of poles of the rotor is derived by an equation, and that is speed of the induction motor is equals to 120 into frequency of the induction motor upon number of poles. There are two types of rotors, squirrel cage type and wire wound or slip ring type. The first type is squirrel cage induction motor. In squirrel cage induction motor, the rotor outer body is designed like a cage and inside it the rotor is housed. But here the outer rotor body, that is cage, is not straight but it is skewed at some angle. And why it is so? There are two reasons behind that. First reason is rotor teeth and stator teeth will not get magnetically locked, and if it gets magnetically locked then the rotor will not operate. There will be no starting torque at the initial starting. So for that the rotor bars are skewed. Outer cage of the motor is skewed at some angle, so there will be some gap between stator and rotor and the rotor will rotate smoothly. Second reason is there will be no magnetic humming inside the rotor. The second type of rotor core is wire wound of double layer, which is known as wire wound rotor. It is also named slip ring rotor. The slip rings are connected at the shaft of the rotor, at the end of the shaft. Slip rings are directly connected to the external resistance circuit. Why the external resistance are needed? They are needed to start the motor for providing higher starting torque. So we can connect as many resistance as we want. When the external resistance are connected to the rotor, it will increase the external mechanical torque and it will make the motor operation easy. And finally here we can see that the stator and the rotor is housed and makes three-phase induction motor. We can use squirrel cage and slip ring induction motor according to their applications. Squirrel cage induction motors are commonly used induction motors, but there is one drawback behind it. It produces very poor torque, so they are used in lathe machines, drilling machines, fan blower, printing machines, etc. Whereas slip ring motors are used in the industries which requires very high starting torque. They are used in hoists, cranes and elevators. Thank you friends. If you like my video, then please like and subscribe, and if you have any doubt regarding this video, then you can comment in the comment box of my YouTube channel, The Electrified. Thank you.